Without steel, modern civilization as we know it would not exist. Yet few African-American male factory workers.
We will follow steel's complete journey. You will see how nature's raw materials are reshaped by technology and engineering.
This documentary takes you deep inside the industrial process that transforms raw iron ore into high-quality steel.
Exits. Steel is one of the most important materials in the modern world. It supports skyscrapers, highways, cars, ships. Producing them requires coordination between mining operations, processing plants, steel furnaces, and finishing lines.
Or underground mines, often covering several square miles.
Now comes the heart of steel bar manufacturing. The red-hot steel passes through a series of heavy rolling machines.
Massive machines, precise chemistry, and human expertise. From deep underground mines to advanced rolling mills.
Iron ore mining, where the journey begins. Every steel product begins its life as iron ore, buried deep beneath the Earth's surface.
Iron ore is a natural rock that contains iron combined with oxygen and other elements. To access it, mining companies operate massive open pit into one of the most useful products on Earth. This is the story of iron ore becoming steel sheets.
Large chunks of ore are delivered to crushing plants, where heavy-duty crushers break the rock into smaller pieces. These machines use powerful steel jaws or rotating cones to apply extreme force.
Once crushed, the ore moves to grinding mills. Here, rotating drums filled with steel balls grind the ore into a fine powder.
This process increases the surface area of the iron particles, making it easier to separate iron from unwanted materials.
Conveyor belts connect each stage, moving thousands of tons of material every hour. Grinding is a critical step because consistency matters. If the ore particles are too large, separation will be inefficient. Dust control systems and enclosed structures help protect male workers and reduce environmental impact.
If they are too fine, material can be lost. East Asian female engineers carefully control speed.
At the end of this stage, the iron ore looks nothing like rock. It has become a fine, sand-like material.
Ready for purification. This preparation sets the foundation for high-quality steel production.
Crushed and ground iron ore still contains waste material known as gangue. Beneficiation is the process used to remove
these impurities and increase the iron content of the ore. One of the most common methods is magnetic separation.
Because iron is magnetic, powerful magnets pull iron particles away from non-magnetic waste.
Magnetic strength and material feed rates in real time. The result is iron concentrate, a cleaner, more valuable product.
Water flow is spiking on circuit 3.
I'm adjusting the intake valve now. Check the levels.
It's stabilizing. Back to nominal.
This concentrated iron is no longer waste-filled rock. It is now an engineered raw material, optimized for high-temperature processing. By removing unwanted elements early, steelmakers save energy, reduce emissions, and improve overall production performance.
Iron concentrate cannot be fed directly into a blast furnace in powder form. It's shaped into solid pieces that allow airflow and even heating. In pelletizing plants, iron concentrate is mixed with binders and rolled inside large rotating drums.
This creates small, marble-sized pellets. The pellets are then hardened in high-temperature furnaces to increase strength. Sintering is another method. Fine iron particles are spread over a moving grate and heated until they partially fuse together. The result is porous chunks known as sinter. Both pellets and sinter are designed to perform efficiently inside the blast furnace.
Their shape and strength allow hot air to circulate freely, improving chemical reactions.
Quality control is essential. Pellets must meet strict standards for size, durability, and chemical composition.
Weak pellets can break apart, reducing furnace efficiency. At this stage, iron is fully prepared for melting. What was once powder is now a carefully engineered furnace-ready material, moving one step closer to becoming steel.
Steel making, refining iron into steel. Pig iron must be refined to become steel. The blast furnace is one of the most impressive machines in modern industry. Standing several stories tall, it operates continuously. Iron pellets or sinter are loaded from the top, along with coke and limestone. Hot air blasts into the furnace from the bottom at extremely high temperatures. The coke burns, generating heat and carbon monoxide, which removes oxygen from the iron ore. As the material melts, molten iron sinks to the bottom, while impurities combine with limestone to form slag.
Pig iron contains a high amount of carbon, making it strong but brittle. While unsuitable for most applications,
Bells. It is the essential intermediate step in steel production. Blast furnaces run non-stop.
Shutting one down is costly and complex.
Engineers monitor temperature, pressure,
and chemical reactions around the clock to maintain stability and efficiency. This stage marks the transformation from solid ore to liquid metal, a dramatic shift powered by heat and chemistry.
This is done by reducing its carbon content and removing the remaining impurities. In a basic oxygen furnace,
This process happens quickly and produces large volumes of steel. Electric arc furnaces use a different approach.
This method is more flexible and widely used in modern steel plants.
During steelmaking, precise control is essential. Small amounts of alloying elements, like manganese and
nickel or chromium, may be added to achieve specific properties.
The manganese levels need adjustment for the automotive panels.
Confirmed. Adjusting the dial now. Looks like we hit the optimal curve for the construction sheets, too.
Or appliance steel, all require different characteristics.
By the end of this stage, molten steel is clean, controlled, and ready to be shaped. This is where iron officially becomes steel.
Once refined, molten steel must be shaped into solid form. Continuous casting allows this to happen efficiently and consistently.
the result is a large rectangular slab, often weighing more than 20 tons. These slabs' continuous casting improves quality and reduces weight compared to older methods. It also allows steel production to run non-stop.
Sensors monitor temperature, cooling rate, and surface quality. Any defects are detected early to prevent problems later.
Steel slabs are now solid, but far from finished. Their journey continues into rolling mills, where size and shape are refined.
Hot rolling shapes the steel quickly and efficiently, but surface finish is rough. For many applications, this is enough.
For higher precision, steel undergoes cold rolling. This process occurs at room temperature and further reduces thickness.
Cold rolling improves surface smoothness, strength, and dimensional accuracy.
Cold-rolled steel is commonly used in cars, appliances, and high-quality construction materials.
Rolling mills operate with extreme precision. Even tiny variations in thickness can cause problems in final products.
By the end of this stage, steel has taken its familiar form: thin, flat sheets ready for finishing.
Finishing, quality control, and final use. Before shipping, steel sheets go through finishing processes.
Galvanizing coats steel with zinc to prevent rust. Other coatings improve durability and appearance.
Every sheet is tested. Thickness, strength, surface quality, and chemical composition are carefully inspected.
And shipped to manufacturers around the world. They become cars, buildings, appliances, and infrastructure.
From iron ore to steel sheet, the journey is complex and powerful. It combines natural resources and an advanced engineering.
Steel is more than metal. It is the foundation of modern life. And